10.3, inscribed angles. An inscribed angle is an angle whose vertex, remember that's the point, that point right there, whose vertex is on a circle and whose sides, these are the sides, contain chords of a circle. So a chord, remember, has endpoints on the circle. So this angle here is an inscribed angle. If you remember from previous section, this angle is a central angle. And in this section, we're going to be talking about the relationship between the central angle and an inscribed angle who share the same arc. Okay, a lot of vocabulary there. If you need to replay that and listen to it again, do so. There's two theorems that we're going to talk about, and I'm going to show them on GeoGebra. Theorem 10.8. And we're going to look at the relationship. This red angle is the central angle. The black angle here is the inscribed angle. And what happens as we move the point around? What's the relationship between these two angles? So I'll try to stop it close to about 120. Notice that's about 60. If I make it real small over here, about 22, this is about 11. And you can make it a really big angle, 170, and notice half of 170 is about 85, 86. So that is the relationship going on in the problem. So in general, if I call this angle x, if this is x degrees, the inscribed angle is going to be 1/2 x degrees. The next theorem, theorem 10.9, I have two angles, this red inscribed angle and a blue inscribed angle, and notice they're inscribing the same arc. Okay, arc HF, they're both intersecting that same arc, and it doesn't matter where these are, when they inscribe that arc, it's going to be the same no matter where the point is. If I change H, that changes. But notice these angles are going to be the same because they're intercepting that same arc. So two angles, inscribed angles that intersect the same arc are going to be congruent. And the relationship between that arc measurement and this angle is going to be half the arc measurement. Remember, the arc measurement is the same as the inscribed angle. So if we know this angle, arc out here, you divide it by 2 to get the interior angle. So for example, in this one, if we call this arc x degrees, and this angle here is 1/2 x degrees, and this angle here is 1/2 x degrees. Okay. Congruent angles. Okay, those two angles are going to be congruent. They're going to have the same measure. So, let's look at this problem. Find the measure of arc ADC. Here's arc ADC. Remember, it's got 3 points, so it's, in this case, a semicircle, 180 degree. That's 360 all the way around, so we know if that's a semicircle, that's 180 degrees. And does that make sense that this inscribed angle here is 90 degrees? And if you double 90 degrees, you get 180. Or take half of 180, you get 90. And that'll be a theorem we're going to talk about in the next page. Find the measure of angle ABC. We want to know this measure. We're going to take half of 196. Half of 200 would be 100, so it's almost going to be 100. It's going to be 98 degrees. 98 times 2 would be 196. All right, we got two more theorems. One theorem deals with when you have a diameter and, where one side's a diameter in a inscribed triangle. What's this angle going to be? And I can show you on the GeoGebra again, but let me pick the points that I can move. So I can move B around. B is always going to make that a diameter, but notice this angle always stays a right angle. And that should make sense from our last problems here. This is always going to be a right angle because this arc is always going to be 180 degrees if that's a diameter. Half of 180 will make that always 90. Now the next theorem is a little bit more interesting, but when you have an inscribed quadrilateral, your opposite sides are supplementary. They add up to 180 degrees. So this plus this, 180. This plus this, 180. Your opposite angles, even if I move these things here pretty close to each other, these a little bit more far away, your opposite angle, 66 plus 113, is going to be 180 degrees. So if that's a diameter, this is always a right angle, and these opposite angles, if it's an inscribed quadrilateral, all the angles are inscribed on the circle. An inscribed quadrilateral, the opposite angles are supplementary. Okay, 180 degrees. So here's a diameter. That means this arc is 180 degrees. That means this angle is 90. 3x equals 90. Divide by 3, x equals 30. B, we have an inscribed quadrilateral. My opposite angles are supplementary. So y has to be 100 degrees so that the two angles add up to 180. And x is going to have to be 95 degrees. So they add up to 180. Now this one's a challenging problem from this section. I know my opposite angles have to add up to 180 degrees. I don't know anything about my consecutive angles here. You know, this is not necessarily a trapezoid. If it was a trapezoid, these would be supplementary as well, but it's not. So what you have to do is you have to say 10y plus 40x equals 180. And also these, 19y plus 22x equals 180. And now we need to solve for x and y. So this is a system of equations. We have two equations, two unknowns. So what you can do is we can manipulate these equations. So I can take this first equation and I can divide it by 10 to get a new equation. Dividing it by 10, I get y plus 4x equals 18. And now I can multiply it by 19 to get things to cancel. So taking, so I divided equation 1 by 10 to get this new equation. Now I'm going to multiply it by 19, so I end up with 19y plus 76x equals 342. So now taking this new equation and bringing this equation down, okay, so I have a new system of equations where I can just add these two things together. In this case, I'm going to subtract them. So my y's cancel. 76 minus 22 is going to be 54x. 342 minus 180 would be 162. And looks like 54 would go into 162 3 times. So if x equals 3, we got to figure out y. So we can come up back to this equation and put in 3 for x. So you get 10y plus 40 times 3 is 120 equals 180. Subtract 120 from both sides. 10y equals 60. So y equals 6. There's a homework assignment. Peace out.